Today we should discuss about what is resistance and the dependence of resistance in various factors. Before going to what the exactly resistance is, we have to know what was happening in the wire or in a conductor. Why the conductor flows current or carry current or electric charge? Why only a charge body or a charge conductor always not flow without adding a EMF? So for flowing the current we have to add a EMF or called the battery. Battery is a system and EM the called the single system of this process. So we add a EMF, electromotive force, to promote a higher potential and lower potential. Everything in the universe flows from higher potential to lower potential. Charge also not an exception of this rule. Charge also follows this rule. So a positive charge follows from higher potential to lower potential, and a negative charge follows the opposite direction of this process. So adding an EMF, we actually make a source from a electric field, that is electric field is equal to E is equal to V by L, where L is equal to length of the wire and V is equal to the potential difference of the wire. Okay, so every conductor doesn't flow the charge because the E in is equal to 0, but here E in not equal to 0 because E in is equal to V by L. So this differs from a conductor which flows charge or not flows charge. Okay, so if a conductor is like this and we give it charge, then all the charge is outside of the conductor or the surface of the conductor, and no charge is inside of the conductor. If the inside of the charge was there, then all the charge will come out from the surface, and no charge actually exists in the surface of a conductor. So scientifically proved that no charge is there in the conductor to exist the charge in the surface or contents in the conductor. So what is happening in this wire which flows the electricity? Actually in this wire there are charge in the conductor, only this happens to this. Okay, and that is why the wire flows electric current. Okay, now what was happening if we giving a potential difference? Actually some object is fall from a height h, and object is throw from this point. So at the initial velocity is equal to 0. Okay, now the decrease of potential energy is equal to increase of kinetic energy. Increase of kinetic energy. So it also follows the conservation of energy. Okay, actually energy doesn't destroy, total energy is conserved, only differs from the state of energy. Actually it is a potential energy change into the kinetic energy, and some energy also transfer into the heat. So here it also follows the decrease of potential energy creates the heat energy, or the energy which we get from the light, or the energy which we get from the sound. That is actually the decrease of potential energy always convert our expect energy. We actually give our electricity to our fan to run it. So the decrease of potential energy actually helps to run the fan. Actually decrease of potential energy helps to bulb glow gradually. Okay, so we have to know that the energy conserved in this process. So according to Ohm law, V varies as I, where the V is equal to potential energy and potential energy between the wire, and I is equal to the current flows through it. So V is equal to IR, where R is equal to proportional constant, where we say that R is resistance and R is equal to V by I. So this is the definition of R. Actually it is a ratio of potential difference and current flows through it. Okay, if we plot a curve in xy axis, we get a curve like this. Y. So is equal to V is equal to IR, or Y is equal to mx, where m is equal to tan theta, or the latitude of the straight line. Okay, so here it is R. Everything in the universe is not a perfect, so there is no perfect conductor, there is no perfect insulator. So for a perfect conductor, R tends to 0, or there is no resistance in the wire. So a wire which follows the ohmic rule always follows the curve, but this curve is not always like this, because the temperature not possible to remain constant, because where the potential energy decrease, it increase also the heat energy, and from the Ohm's law we say that it is not possible if all the physical state isn't constant. So we have to know that the physical state and temperature is equal to constant to follow this curve. So actually there are three types of main conductor in this universe. This is called the superconductor, second is semiconductor, and third is ohmic conductor. Okay, so now we know about how the electron or a charged particle moves through the conductor which follows the current. So this is a wire of length L, and there is, now we consider a single plus positive charge. Okay, now we set a potential V. This is a potential about V. Now we know that at the first I said that V is equal to E is equal to V by L. So E is equal to V by L, where E is equal to electric field in the wire. We also know F is equal to QE, where the Q is equal to the charge of the particle in Coulomb, and E is equal to electric field. Okay, in the same. Okay, now we say that this feel a force in the direction of electric field if this is positive and this is negative, and the value of the force is F is equal to QE is equal to QV by L. So this force feel by the particle, charge particle. So after feeling this charge particle, force of this charge particle, the particle actually not move in a such way that actually feel, because there are so many charge particle in the conductor. So what we actually imagine, there are tons of, there are million and billions of electron and proton there. So if this move through, they collision each other, and that is why they get a drift velocity. The drift velocity is not exactly what we give the value of force and what the expected range of the velocity. It is a velocity after a number of collision. So if a particle move through this and it collision like this. It is a path of a particle, charge particle exactly. So the initial and later position is the same. Initial and final position is exactly same, not differs anymore. But if we apply an electric field there, so the initial and final position not exactly same. It will be get a distance like this. So the what is about the final and initial position? It is called the VDT, where the VD is equal to drift velocity. So how it possible that if we switch of our electric current and our light was in light quickly, not waiting for some times. Okay, that is because that when we set the electric field of the wire, it is from end to end. Okay, so there is the exactly same value of electric field from the position from this end and this end. So if we set the electric field and then the electron moves from this final position, is happens to glow the light. So it is a simultaneous process that if we switch on electric wire, then we get light simultaneously, because this is happens that electric field was set up in the speed of a light. Exactly, it is the same speed which our light travels in the vacuum. And later we know that dual nature of electromagnetic theory, where there we can discuss about it further. Okay, now without any things we should go the dependence of resistance in various factor. Okay, now we discuss about this topic. So at the first we should discuss about the changes of physical shape keeping volume constant. So here we not add or subtract any wire of length L, cross section A, mass always remain constant M. So area of cross section is equal to A, mass is equal to M, length is equal to L. Okay, and all other physical property will remain constant, like the resistivity. Okay, now first question. So at the first we should discuss about the question: if the wire stretched to double its length, find the final new resistance if the original resistance remain constant. And the original resistance is R, we say. Okay, now here the volume remain constant, and what is actually asked? Double its length, final resistance. So they ask the resistance if they double its length. Okay, now we draw a picture. This is a wire of length L, and we stretch it double of its length. So we know that the area of cross section will decrease. Okay, now the resistance is R and it is R dash. the new resistance will be. So volume is equal to constant. So we know that R is equal to rho L by A, or R varies L by A. So actually they save the changes of L. Okay, now R varies L by A into L by L. We actually, the L by L is equal to 1, so this doesn't affect. Okay, so R varies L square by V. As the V remains constant, we actually do these types of math to remain the, say that V is constant. Okay, so R varies L square, we get the relation that R varies L square. Okay, now R1 by R2 is equal to L1 by L2 the whole square is equal to, if it is L and it is 2L, then 1 by 4. অতএব, so R by R dash is equal to 1 by 4, or R dash is equal to 4R. So it is 4 times of the old resistance or original resistance. So if we stretch a wire, the resistance will increase by 4 times. So I also say that if the data was given that the length is given, then we do these types of math, L by L, multiply by L by L. Okay, now we are coming at the second question. Second is, if the radius of the wire is R, then what will affect? What is new resistance? And we get the relation. Okay, now we know that R varies L by A. So it is given that the radius of the wire or the cross section is given, because A is equal to 4 pi R square. So A is given, so we multiply A by A. Okay, R varies L by A into A by A. So R varies V by A square. If the V is constant, then R varies 1 by A square, and A varies R square. So R varies 1 by R to the power 4. So R1 by R2 is equal to R2 by R1 to the power 4. Okay, now any problem is given in these types, we will use this relation, that R1 by R2 is equal to radius of second wire by radius of first wire to the power 4. Okay, now we am doing that a problem number 3. If the wire is stretched to increase the length by 1%, find the percentage change in the resistance. Find the percentage change in resistance. So what is called the percentage change? Percentage change is equal to actually R by R into 100%. Okay, we have to remember this. So before going to doing this math, we have to inform that if this value is less than 4 then, or less than 5, if the value is less than, then we actually use these types of math. If this value is more like 10% or 20%, then we not use this method, because there was occur some error, a error of 0.1 to 1% between the 4 to 10% increasing the length was occurred, so we not get the exact value and we will not follow this. If so, we will do the math in the next question, where the increase of length will be 10%. okay, now we will do it by 1%. Now by the previous method we saw that R varies as L square if the volume remain constant. So delta R is equal to 2 delta R by R is equal to 2 into delta L by L. It will do by the derivative, because the power is come, like the d by dx of x to the power n is equal to n x to the power n minus 1. We will use this formula. Okay, now delta R by R, actually we know that using of derivative when there is a small infinitesimal portion of the math was happen. So 1% is exactly not the infinitesimal, but we can do, and it's occur a small error. But if we take a long distance, then we not use the derivative. So actually we use derivative because the length, the increase of length is only 1%. So many students do this wrong way. 100% is equal to 2 into del L by L into 100 equal to 2 into 1%, so 2%. So the resistance will increase by 2%. So if the wire is stretched to increase by the length by 1%, then the resistance will increase by 2%. okay, now we do the math when the increase of length is 10%. Length stretched by 10%, then express the change of resistance in percentage. Express the change in resistance by percentage. Okay, now we know that R1 by R2 is equal to L1 square by L2 square if volume is equal to constant. Okay, now the percentage change of the resistance can be shown, because we not use the derivative, so we cannot use like R by R into 100%. we not actually use in this process because the length is more than the 4%. okay, now we should use this formula, R2 or final resistance minus initial resistance by initial resistance into 100%. okay, now percentage change of resistance is equal to R2 minus R1 by R1 into 100%. So because the we know that the initial length is is equal to L. Final length after stretching by 10% is equal to L plus L so this is 1.1 L. Okay, so we do this R2 by R1 minus 1 is equal to L2 square minus L1 square minus 1 or L2 square minus L1 square by L1 square. So this is 1.1 L the whole square minus L square by L square. So 1.21 minus 1 0.21. So percentage change is equal to R1 by R2 by R1 minus 1 into 100% is equal to 0.21 into 100% is equal to 21%. So if we do this math by the using of derivative, then we get exactly 20%. If we do the math using derivative formula, then we get 2 into 10% is equal to 20%. That is not the same value, so the accurate value is 21%. So if the stretch is more than 4%, then we use this formula. Okay.